Okay, so let's see. I left off. We got to this problem because yes, we just saw this, and now we are here. This is like test problem number 5, number 4. We'll figure that out. So it says consider the following circuits with 3 ideal batteries, 5 resistors. Using Kirchhoff's rules, find the current in each resistor shown in the figure. Find the potential difference between points C and F. Oh, that's that's the extra credit. Okay. So let's say that the loops are in this direction and in this direction, kind of mirroring this. I can do it. That was flawless. Yeah. This is going to be the point right there. This is going to be the junction. So we're going to need a junction equation. And let's call this current 2, because that's resistor 2. This is going to be current 1, and this is going to be current 3. So, I don't know if I'll do all the color coding nonsense. Keep track of it, why don't you? Come on. Current 2 equals current 1 plus current 3, because currents in equals currents out. Current 2 goes in, current 1 and 3 come out. Which means that I1 minus I2 plus I3 equals 0. Okay. That's junction equation done. Now, we're going to want to study loop 1. We're going to call this loop 1. We're going to call that loop 2. Alright, okay. Loop 1, let's just start them off from E2. A good reference point. So current 2 comes up. No. Let's start with E2. E2. Current adders versus current resistors. So it's going to be E2 minus E1. And that's going to be that. So E1 is going to actually go to the other side. And then we're going to have plus I2 R2. Or does this be? Yeah, I2 R2 plus R1 I1. I could call this I1 R1. And then it's going to be plus I1 R4. Okay, good. Boom. Bam. Let's do loop 2. It's going to also have E2. But if you look here, this is going to be the negative side. That's the positive side. This was positive side, negative side. And we were going this. We were crossing positive to negative. This time we are crossing negative to positive. So that's actually going to be plus E3 equals I2R2 plus I3R3 plus I3R5. And that's that. Now, let's see. It says find the current in each resistor. Okay, alright, okay. Here we can say junction equation goes on top, loop 1 goes here, loop 2 goes here. And we're going to create a matrix. So this is going to be a 1 minus 1, 1. It's going to equal the inverse here. Or inverse here is going to be 0. And then finally that's going to equal something. And loop 1 is, I guess, E1 minus E2 is going to be 7 minus 6, so negative 1. 6 take away 7, negative 1, I mean. And that's going to be I1, I2, I3. I1 is going to be equal to R2. Oh boy, how does this go? Don't we have to solve for a current? Oh, yes, we're given what they are. I1 is equal to 0. We have actually, oh, sorry. I was looking at the wrong loop. I1 is going to be R1 plus R4. R1's 3, R4 is 17, so it's going to be 18. R2 is equal to, or I2 is equal to R2, which is just 9. And we have no current 3, just current 1s and current 2. I2 here, but they're going to have an I3, which is going to be I3 comes to the outside, and then it's I3, R3, R5, 5, 25, so that's going to be 30. I2, R2, 9 and 0, and then this is going to be E2 plus E3, which is going to be 9 plus 8, which is going to be 17. 17. Scroll through this. Yeah, it's looking, oh. Here. This should be 20. Current 1. R1, R4. 3 plus 17. I'm an idiot. 20. Okay, the rest. Oh, this should be 14. Why is this 14? E2 plus E3. 6 plus. Oh, because it's not 9, it's 6. I was looking at that. Okay. And now when you put this into the calculator, matrix here, 1, negative 1, 1, 20, 9, 0, 0, 9, 30, and then matrix B is 0, negative 1, 14. And then you get out of that and you do matrix A to the negative 1 inverse. That's going to be times vector B. So I'm getting negative 0.16, 0. Oh, I can probably do this for here, 0.23 or 24, and 0. They're gonna be 40, 40. Yes, and it's gonna be in amps. And to remember what these are, it's I1, I2, I3 left to right, which means it's I1, I2, and I3 top to bottom. What a fun problem. And then it asks, find the volts coming across the nonsense. The thingamabob, I think they called it. Is this seriously not a black background? Whoops, what? Well, at least I have my purple still, but... Oh, I'm still writing in black. Okay. So what is the voltage from point C to F? Well, let's see. No pun intended. The current across this is going to be I2. So it's 0.29 flowing backward, or 0.24. Oh, come on, dude. So yes. It's going to be minus 9. Current, this is resistance. Potential difference. Change in voltage. V equal. What happened there even? What happened there even? V equals IR. This is I. That's that's R. So that's gonna be. It's actually gonna be multiplied here. 0.24 times 9. That's 2.16. The delta V equals 2.16. However, it's going to be subtracting 6 volts here, which is going to be 3.84. Or in this case, they just want it as 3.8 volts. It's going to be like the absolute value, I guess. So yes, that is that's this problem.